Hello everyone, this is Lens Technology. In the first season of our video series, we covered many types of testing labs and showed you the household appliances around us. Lately, many of you have messaged us asking about commercial appliances. For example, those used in shopping malls, hotels, and data centers, which are heavy users of cooling. What kind of air conditioning system provides a continuous stream of cold air behind the scenes? That brings us to the heart of large central air conditioning systems, the water-cooled chiller. To put it simply, the working principle of a water-cooled chiller is like a heat mover. Its job is to move heat from inside a building to the outdoors. How does it do that? With the four key refrigeration components, the compressor, evaporator, condenser, and throttling device, which form a closed-loop cycle. In the evaporator, low-temperature refrigerant absorbs heat from chilled water, lowering its temperature so it can be sent to room terminals for cooling. After absorbing heat, the refrigerant turns into a gas, is pressurized and heated by the compressor, and then enters the condenser. In the condenser, the high-temperature refrigerant transfers heat to the cooling water, condenses back into a liquid, passes through the throttling device to reduce pressure, and returns to the evaporator to absorb heat again. This cycle repeats, and the heat from the room is continuously carried by the cooling water to the outdoor cooling tower, where it is dissipated. So why is it called water-cooled? The key lies in how the condenser dissipates heat. Instead of using air, we use cooling water to carry away heat. Water has a high specific heat capacity and excellent heat exchange efficiency. It's like equipping the chiller with a water-cooled radiator. Compared to air-cooled units that use fans to blow air over the condenser, water-cooled chillers can operate at lower condenser temperatures, reducing compressor energy consumption. How significant is this advantage? For the same cooling capacity, the energy efficiency ratio of a water-cooled chiller is often 30% higher than that of an air-cooled chiller. The larger the project, the more obvious the energy savings. To help you visualize, let's look at the structure of a typical water-cooled chiller. It mainly consists of a compressor, evaporator, condenser, throttling device, and a control system. The compressor can be thought of as the heart of the unit. Common types include scroll, and centrifugal compressors, each suitable for different cooling capacities, from small to large. The evaporator and condenser are typically shell and tube heat exchangers, with dense bundles of heat exchange tubes inside. This allows water and refrigerant to efficiently exchange heat through the tube walls without mixing. The control system acts as the brain of the unit, continuously adjusting the compressor speed and expansion valve opening to keep the chiller running efficiently and smoothly under various loads. Because of this principle and structure, water-cooled chillers offer several outstanding advantages. First, high efficiency, especially suited for large buildings that require year-round cooling, leading to lower operating costs. Second, long service life and good stability. The compressor operates in a relatively mild environment, not directly exposed to high outdoor temperatures, dust, or sand like an air-cooled chiller. Third, large capacity and flexible configuration. Multiple chillers can be easily combined to provide thousands or even tens of thousands of tons of cooling. Applications that demand large, uninterrupted cooling, such as data centers, large commercial complexes, and industrial plants, almost exclusively use water-cooled chillers. Of course, water-cooled systems also require cooling towers and pumps, so the initial investment and footprint are slightly larger than those of air-cooled chillers. However, these additional costs are usually recouped quickly through long-term energy savings. In summary, a water-cooled chiller is a large refrigeration unit that uses water as a medium for highly efficient heat dissipation. It is powerful, energy efficient, and a key contributor to energy saving in large air conditioning systems. As a technician in the refrigeration industry, I believe that selecting the right chiller is the critical first step in designing a good cooling system. That's all for today. In the next episode, we'll dive deeper into how to test and evaluate these large units. If you have any purchase needs for testing labs or similar products, or if you have very interested in refrigeration and energy-saving technologies, feel free to contact us. Don't forget to like, save, and follow. See you in the next video.